Hey guys, I'm Tiger and I'm going to teach you about C++. If you haven't checked out part 1, you should check it out first. Link is in the description. Hit that like button if you learn anything in this video and click that subscribe button if you want to see more videos on C++. So let's start off with variables. So data is information that can be moved, processed, or stored on a computer. So programs take data and manipulate them to produce a desired result. Programs can acquire data in multiple ways, including user input, file access, and information inserted directly in the source code. So like in our Hello World example, the Hello World was inserted directly in the source code, and then the computer stores it in a more efficient way called binary, and the program then manipulates the data by displaying Hello World in the console. So all computers have RAM that programs use, and some operating systems use virtual memory, but we can still picture it as the same. So memory is divided into individual bytes, each having a unique address. A piece of data stored somewhere in memory is a value. And some older programming languages, such as Apple Basics, allows users to access these values directly by addresses. But for modern programming languages, such as C++, these values are accessed indirectly via an object. Now, objects can be named or unnamed. But unnamed objects are anomalous, while named objects are called variables. To declare a variable, we use a type of declaration statement called a definition. We'll get into the difference between them in a different video. So at compile time, or when the program is compiled, when the compiler sees a definition statement, and in this example it's in line 1, it makes note of the variable of type x, and from that point onward, whenever the compiler sees x, it knows we are referencing that variable unless it goes out of scope, and we'll discuss what that means in a later video. So at runtime, or when the program is run, the variable is instantiated, which means variable is created and assigned a memory address. So instantiated objects are called instances. So basically this variable is also called an instance. A data type, or more commonly known as type, tells the compiler what type of value an object stores. So in the last slide, we got introduced to the type int, which stands for integer. So integers are numbers without a fractional component like 1, 5, -2, and 100. But we can say that x is an integer variable because it stores integers. So over here, x stores an integer because it's a type int. And the integers is only one of the many primitive types or types supported out of the box. So double is another primitive type that holds numbers with a fractional component, such as like 0.5, 2.0, -16.2, and 4.7. Well, note that doubles can hold integers such as 2.0, but integers can't hold doubles without losing precision. So over here, y is double over here. And C++ also allows users to create user-defined types, which makes C++ powerful, but we'll get to that in another video. Defining multiple variables. Although it's not recommended, it is possible to define 2 or more variables of the same type in the same statement. The 2 common mistakes when using this practice is repeating the type or attempting to define variables of different types in the same statement. So in our example, these 2 variables are defined in separate statements, but we can put them into the same statement by doing like int a comma b instead of int a and int b. And then the common mistake over here, we put int twice. This practice is not recommended because when the code gets increasingly long and span multiple files, like forgetting the comma will cause a cryptic compiler error that does not tell you where the omission is. And variables can be defined or initialized once before it goes out of scope, or there will be a compiler error. And basically it's called collision. The example will compile partially because of this reason. So like over here, it's not going to compile because we have A a bunch of times and then B a bunch of times. And also a different mistake that some people make is putting different types in here. This also won't compile. And then one type of fix is to replace the comma with a semicolon. This is already two statements, but it's better to make them into two lines. So now let's move on to assigning and initializing variables. Well, variables can be assigned a value after it's defined with the equal sign, with the assignment, which is known as the assignment operator. This process is called copy assignment, or assignment for short. The copy assignment copies a value from the right-hand side of the assignment operator to the left-hand side of the operator. So a variable can be assigned a value more than once, and because normal variables can only hold one value at a time, the old value is replaced with a new value. A common mistake is to confuse the assignment operator with a comparison operator. So over here we've declared x, and then we can assign a value 3 to x, and then now x holds 3, and then we can assign 4 to x, which will replace the 3 to a 4. Basically, the previous value is overwritten. So the downside to variable assignment is that variables must be defined before the assignment. So like in our last slide, we have to do int x before we use an assignment statement to give it a value. So variable initialization creates and initializes the variable with an initial value in one statement. So C++ supports three basic ways to initialize variables:
copy initialization,
direct initialization,
and
brace initialization.
So copy assignment uses an equal sign, which is kind of like the copy assignment operator,
which copies the value from the right-hand side to the left-hand side. And then direct initialization uses parentheses. So for primitive types such as integers, copy and direct initialization is essentially the same, but for more advanced types, direct initialization gives a boost in performance. And not all types can be initialized with copy or direct initialization.
So C++11 added brace initialization.
It's also known as uniform initialization. Brace initialization comes in two forms, one with an equal sign and one without an equal sign. The one without the equal sign is preferred. And initializing a variable with empty braces is called zero initialization because it sets the variable to 0 or empty. So we have some examples of initialization over here. So this one is copy initialization because it uses the equal sign. This is direct initialization and it uses parentheses. This is direct brace initialization, which is the brace initialization without the equal sign. And then here's the copy brace initialization, which is the brace initialization with the equal sign. And also we have the zero initialization, which is a type of direct brace initialization.
Because there's nothing inside the braces, x is set to its default value.
And for integers, it's 0. And the direct brace initialization is a preferred type of initialization, but for primitive types, the differences are negligible, like except for the brace initialization, like where implicit conversion is not supported. So like over here, if we try to put 2.5 in x, with brace initialization, 2.5 isn't converted to 2 before it's put it into x,
which will cause a compiler error.
Always initialize variables upon creation, except for specific cases, like when you're creating a bunch of variables and performance is really important. And also prefer explicitly setting a value to 0 over 0 initialization if the value is actually used. And also there's no direct or brace assignment in C++. So there's only direct and brace initialization, no direct and brace assignment. Now moving on to initializing multiple variables. So just like defining multiple variables in one statement, it is possible to initialize multiple variables in a statement, but it is also not preferred. And it's also for the same reason that it's not preferred. But all variables have to be of the same type, like in variable definition. So like over here, we have copy initialization, direct initialization, brace initialization. Basically, we can just define each of them. And then mixing variable definition and variable initialization may or may not cause the compiler to complain depending on the type of compiler used. So if we mix variable declaration and copy initialization over here, the compiler may or may not complain, and then if it does, G is going to be uninitialized. So thank you for watching, and make sure you fully understand each concept in this video. If you get stuck, remember to leave a comment about whatever you're stuck on so that someone can help you. I'll see you in the next video. Bye.